So fine guys, let's start. Okay. So yesterday we have started the univariate analysis. Okay. So first thing we have seen is a frequency table. Okay. In that we have seen two cases. One is the categorical part and one is the numerical part. Fine. So just to mention, in numerical, because the data will be continuous, you cannot find out the probability for each and every possible outcome, because the possible outcomes will be infinite over here. So that's why you will be converting them into bins. Okay, fine. So now today let's try to see some graphs. Okay, and how we can display these uh, data, like different types of data. Fine. So broadly uh, there are like many graphs which we are going to see. Okay, so but fundamental graphs are three: histogram, bar plot, and scatter plot. Okay, so these are the three graphs, guys. So first let's try to understand what is histogram. Okay, histogram is the graph which can be used to understand for the continuous data. Okay, so histogram looks like this. Yeah. Okay, as you can see, these are all bins. Okay, these are all bins. Fine. So whatever you are seeing these peaks, for example, see this, 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 wherever you are able to see a column sort of thing, so all those are bins. Okay, so now as i said as I said, for the continuous data, what we are doing, we are doing the bins, right? So that's why these are called different bins. The histogram, so the wherever you are seeing something like this, right? For example, so all this, okay, all this one bin, and from here to here another bin. Okay, this will be another bin. Okay, bin 1, bin 2, bin 3, like that, guys. Okay, so this is how a histogram looks like. Okay, and there are different types of histograms, okay, based upon the nature of the continuous data. It could be symmetrical, that means as you can see, this is almost symmetric, right? So it will be symmetrical, or asymmetric, like to skewed to the left, which we have seen, skewed to the right, uniform, almost same, bimodal, multimodal. See, what is mode? Mode is the one which is where you are having the maximum value, right? So for example, we have seen for categorical data mostly mode will be used. Okay, and what is this graph? Actually, this graph is the frequency distribution graph. Yesterday we have seen, right? So on the x-axis we have the outcome, right? On the y-axis, what we have? The frequency. Y-axis is for the frequency. Fine. So now wherever you are having this peak, right? Wherever you are having this peak, right? So that means what? That this particular point is having the maximum frequency. Correct? This particular point is having the maximum frequency. That means what? That is occurring maximum number of times. Frequency is what? Which is occurring maximum number of times. So obviously that will become the mode. Mode is what? Mode is the one which occurs the maximum number of times. Fine. So this, you will have the mode over here. Okay. But in this graph, it is unimodal because it is having only one peak. Okay. But you can find certain histograms where you will have like two modes. Okay. This looks like mode and this also looks like mode. Okay. Over here and over here, or multimodal. Okay, this this. Okay, so three peaks. Fine. So these are different types of histograms. Okay, fundamentally, histogram is what? Histogram is a graph which is drawn for a continuous data. okay, which is drawn for a continuous data. Fine. So we will also try to see an example for this. Okay, don't worry, we'll be seeing example how to draw this. But second type of graph is called as bar plot or bar graph, guys. Okay, this is drawn. Okay, bar graph is drawn for a discrete data. Okay, and yeah, yeah. So this is drawn for discrete data or categorical data. Okay, bar graph is drawn for discrete data or categorical data. Fine. So let's see an example and come back so that you will understand this. Okay. So, okay. So here, if you see, okay, I'm randomly taking some values, okay, for column A, column B, and column C. Okay, rand n. Okay, from random module, oh, if you remember, has a function inside it rand n. Okay, and you are having 3000 values, 3000, 3000. Okay, so here I'm just adding plus one here, exactly 3000. Whatever the value you are getting here, I'm taking minus 1, the value which is generating over here, that will be, from that we are subtracting minus 1. Okay, so there's a different ways you have generated the data, and you can see this is where columns. Okay, ABC, any column you can take. Okay, but here we have generated the data, that's it. So now if you want to draw a histogram of these, okay, you can just say, see, my data frame is df hist. Okay, df hist dot plot, okay, dot hist, okay, dot plot dot hist. Okay, so these graphs, right? So you can draw it in different ways, guys. Okay, different packages. So you can also use simple numpy to draw the histogram. Sorry, not numpy, matplotlib. Okay, matplotlib is for the what is for the visualizations only. Okay, you can use simple matplotlib for the graphs, or you can use something called a seaborn, which we'll be seeing for the graphs, or direct data frame also some have some basic graphs, okay, like histogram, bargram, scatter plot. Okay, so now here using the basic function dfhist dot plot dot hist. Okay, and what is this alpha, we'll see. Okay, but if you just do this, right, so it will give you this. It will consider all the columns in this data frame, like it is some 3 columns, and it will draw the histogram. Okay, it will draw the histogram for each and every column. As you can see, A, B, C color codes. Blue is A, orange is B, green is C. Getting? And usually by default, it will consider 10 bins. Okay, what are these? These are not categorical data, right? These are like what? These are continuous data. So if it's a continuous data, what is histogram, right? Histogram is also frequency distribution. Okay, see, try to understand. Histogram fundamentally is what? Is just a frequency distribution graph. Okay, it's just a frequency distribution graph. The moment when I say frequency distribution, what does it mean? It means what is the frequency of each and every outcome of this column. Getting? If this column is simple green, red, some colors, if green, red, orange, okay, then this becomes categorical in data. And if I have green 100, red 200, orange 50, okay, so the graph will be something like this. You'll have green, red, orange. Green is 100, red is 200, orange is 50. So it will be something like this if you join. Okay, or if you don't want to join, it will be just green will be this, red will be this, okay, orange will be this. Okay, so because here you have fixed categories, and you also have what is the frequency of each and every category. So this graph is more easy to draw. Okay, if the value is categorical. But now here in the histogram is basically designed for the continuous data, guys. It's a frequency distribution graph, but it is basically invented and discovered for the continuous data. In continuous data, as you can see, if you consider column A, right, almost every value is unique. Can you see? Randomly it has generated almost every value is unique. The point which I'm trying to make yesterday also, right? See, every value is unique. So that means what? Total 3000 unique values you are having. So what are the possible outcomes of column A? Okay, so any frequency distribution is what? One is outcome, and second thing is the frequency of each outcome. Correct? For discover, one is outcome frequency distribution, and second thing is frequency of each outcome. So now for column A, there are 300 outcomes. Okay, 3000 outcomes. Fine. So obviously you cannot calculate the frequency of each and every outcome. Even though if you calculate, okay, even though if you calculate, it will be almost one, because every value is almost unique. So that means what? Every value is repeating only once. So the frequency of each and every value is one. So this is obviously not going to be helpful, right? So that is the reason for continuous data, we will try to bin the data, right? We'll try to bin the data. Okay, so some bins we will be taking. Okay, and then that will be kind of converting this into categorical. The bins will act as a categories. Okay, fine. So now, as you can see, when I say A, B, C, for example, let's simply see what is for only column A. Okay, see, for only column A, if on column A you can specify column A. Fine. So now this has automatically considered the bin. See, this is one bin. Okay, this is one bin. This is one more bin. Fine. This is one more bin. Okay. Getting this. So by default, it will consider some division for the bins. But if you want to mention the bins also, you can also mention over here. Like what should be the division, from what value till what value you want to consider first bin, and second bin range should be what. Okay, you can also do that. Fine. So I'll be showing you in coming exercises. Okay, but basically the simple histogram plot you can draw in this way. Clear? And here the alpha is the one, it is just the brightness, guys. Hmm. Good question, Sirisha. Bin means what? Yesterday class did you go through? Obviously you will not understand, right? So as I said, don't skip the class. Even though if fine, even if you skip the class, you should go through the recording. Yesterday clearly I have mentioned what is bin, what is group. So is bin cleared for you, Meghana? Like, do you have understanding, like what does a bin mean?
Yes, sir. Clear. For frequencies, we take in the form of bins or buckets.
Correct. Yeah. So obviously she has attended the class. She know that, right? Fine. So as she said, just to give an idea, bins are just buckets or groups which we divide the given data into. Fine. So the overall data what we are seeing over here, okay, see this complete data, its range might be from, let's say, if 1 to 10. Okay, 1 to 10. Fine. So from 1 to 10 you are having how many values? 3000 values. Okay, so 3000 values. So obviously 3000 values you are having, so you cannot calculate the probability of each and every value. That's why we'll divide this overall 1 to 10 into certain bins. Okay, from 1 to 3 or 3 to 5. Okay, you will convert into few bins. Okay, this is a basic idea. But yesterday I have clearly explained in detail what is the reason of bins. So once you go through the recording yesterday, you will get a good picture. So that's why I said, so this is the reason. So before starting the stats class itself, I mentioned one point saying that the stats class, it's like a chain, right? So every concept what we are studying, so will be used in the next class. Okay. So what all you are studying today, so is completely used in tomorrow's class. It's just extension of each concept. It will be slowly unfolding itself. Fine. So if you miss the chain, it will be very difficult for you to understand. It's not like Python. In Python, if you don't understand loops, you can understand exception handling. That's fine. Even if you don't understand exception handling, you can understand file handling. That's fine. Then they're not like complete dependency. But here it's just combination of different concepts will create a new concept. Fine. So obviously you should not miss the link. Okay. So better take some time and go through today's recording. Okay. So now here the alpha is just the brightness of this graph is. Okay. So if I change it to very low, the graph will be very low. And if I change it to maximum 0.9, it will be very dark. Okay, that's it. So now to give for any particular column, you can say as column A. But if you want to draw for each and every column, you can use this. Okay, fine. So that is the histogram regarding the continuous data. Coming to bar graph or bar plot. Okay, this is basically for discrete or categorical data, guys. Okay, so that means what? So I am creating a data. So PQR values are this. Okay, labels values. Okay, PQR 720. That's fine. Fine. So now if I try to draw a graph bar plot. Okay, so the way how you can do is df dot. This is my df dot plot dot bar. Okay, x is my labels, y is my values. Okay, so what are the labels? Labels are this PQR, y is my values. Fine. So if you just draw, so it's a very simple graph. Okay, see P Q R, and P is what? 70 25 97. Fine. P is 70. This is 60 80. Here you will have 70. Similarly, somewhere here 27 and here 97. Fine. So this is the bar graph. It will just tell you the frequency of different values which you have over here. Fine. So this is for the discrete values, guys. Okay. So, but now you should be getting like what is the fundamental difference between histogram and a bar gram. Okay, bar plot. Okay, histogram and a bar plot. Fine. So it might look same. Okay, it might be initially it might be a bit confusing, but there are few fundamental differences which you should know, guys. This could be an interview question actually. Mostly they'll ask. Okay, see over here if you observe a bar chart and a histogram. Okay, even though they look like same, they're like completely different things. Okay, the first and foremost thing you should always understand here, guys, histogram is for the continuous data. Okay, histogram is for the continuous data. That is the most important thing. Okay, as you can see, it is for the continuous data. Okay, bar chart is for the discrete or categories. Okay, discrete data or categories data. Okay, so now for that reason you can understand. For that reason you can understand if you are if you have noticed one thing, the difference between bar graph and the histogram. If you see here, there are some gaps, right? So there are some graphs between the bars. Okay, but here if you see these bars, okay, these columns, okay, okay, for designs, you don't see any gap between them. You don't see any gap between them. Agree? That is very very important point. By looking at the graph itself, you can say whether it is a histogram or bar plot. Okay, in histogram there will be never any gaps, no gaps between the bars. See, everything is continuous. Okay, but here in bar plot you can have gaps. Okay, you can have gaps. Clear? But why is it so? Again the same thing. For histogram there will be no gaps because the histogram itself is drawn for continuous data. Fine, itself is drawn for a continuous data. And how we are drawing the continuous data? By creating bins. Fine. And when you're creating bins, as I said, if you take a range of 1 to 10, okay, if you take a range of 1 to 10, obviously you should, how you will create bins, you will say from 1 to 3 first bin, from 3 to 5 second bin, okay, from 5 to 7 third bin, from 7 to 10 fourth bin. As you can see, there are no gaps between these bins, right? You want to consider every possible case. Fine. You cannot say 1 to 3 is first bin, and next if you consider 4 to 5 as second bin, what happens to 3 to 4? Right? You cannot miss the data, right? That is the reason. So because you are creating the bins, or histogram itself is creating the bins in the background, but it will also create in the same way. Fine. So it will divide the complete given range of 1 to 10 into certain bins where there are no gaps between the bins. Fine. So 1 to 3 will be first bin, and again from 3 to 5 will be second bin. 5 to 7 will be third bin. 7 to 10 fourth bin. So every value you take should fall somewhere in between. Any new value that is coming should be belonging to one of these bins. Fine. So that is the reason that since there are no gaps between these bins, you cannot see any gaps over here. So histogram will always be continuous, guys. Always remember that. Fine. But coming to bar plot, these are what? These are just discrete values. There is no relation between P or Q or R. These are all different values. Okay. For P there is some separate frequency. Q there is separate frequency. R there is some separate frequency. Fine. So there could be gaps between these. Is this clear? Is this point clear, guys? Are we good till now? What is histogram continuous and bar plot, and why there are no gaps between histogram, and why there could be gaps between bar plot? Let me know, guys.
Clear, Sandesh.
Okay. And one more important thing here is the width. Okay, one is the gap, and second thing, the width over here, right? The width in the histogram is important. Okay, because the width here is speaking about the bins. Agree? What are these? These are the bins, right? See, if this is -4, okay, if this is, let me call it as -3, fine. So what is this width? This width is -3 to -2. Okay, this is an interval, this is a range. Fine. So from here, if I call it as 2 to 3, so okay, from 2 to 3 you're having one more bin, right? So this is important. So the width, if the width is increasing, that means the bin is becoming wider and wider. Agree? So from 1 to 10, if I consider only 3 bins, I can have from 1 to 4 as one first bin, 4 to 7 second bin, 7 to 10 third bin. Okay. So then when you try to plot these, okay, when you try to plot this, how does the graph look like? Roughly it will look like from 1 to 4, right? So first bin will be 1 to 4, and then 4 to 7, and 7 to 10, right? So it will look like, so you will have this, okay, and 4 to 7, 4 to 7, this is the range, and you might have something like this, okay, and 7 to 10 you might have something like this, okay. This width, okay, this widths, okay, are bit longer. But if you consider smaller bins, okay, this will have, the width will decrease, right? 1 to 2, 2 to 3. If you take one value for each bin, 1 to 2, 2 to 3, 3 to 4, 4 to 5, okay, what happens? So it is becoming smaller width, right? Getting, so the width is getting decreased. So the width are actually important for here. Okay, the width are important because the width is actually telling you the what is the interval of that particular bin. Fine. And you can also understand, if the width are wider, that means bins are few. Fine. As the width of the bin is decreasing, it means that you need to have more bins. Simple, right? If the width of the bin is increasing, you can have only few bins. Fine. That is this width, guys. Okay. The upper part, what you are seeing, this part, this is frequency. Okay. If it's confusing, this whatever you are seeing here, this is frequency. That means what? You will have on the y-axis what you are plotting. On the y-axis we are plotting the frequency. On the x-axis we are plotting the bins. Okay, so I'm saying on the x-axis, if this width, okay, if this width is more and more, that means it means that the bins are little wider bins. Okay, but if this bins are less and less, what then what? The bins are of are very like thin bins, and you need to have more bins to cover. Getting? But here, but in the bar plot, these widths are with this width are of not any importance. Okay, it is just telling you the height is important. Okay, because for p, what is p is 70, right? The p is 70, that's the only thing important. Okay, p 70, fine, that is the only thing important. The width of this bar is not important. Okay, so even you can also just say small width. This also means 70, because the only thing I should understand from here is p should be pointing to 70, that's all. So even if you draw a single line also 70, or if you give a width, large width also 70, or a medium width also 70, the width could be anything, that is not pointing like referring to anything. Okay, here also you can just have this small also, it also work, fine. Okay, so that's why if you go over here, so the gaps, there are gaps in the bar graph. Okay, first thing, gaps. Here you don't have gaps, and there are different widths. Okay, they could be of different widths, fine. But in bar graph, the all the width will be almost same, because the width is not having any importance, right guys? We are just we just want something to represent over here, so that it will denote the frequency. So we are using these bars. Okay, so the width is not actually having any importance, so that's why all the width will have the same width. Okay, same width. But in histogram, this each bar is actually denoting what? Is actually denoting one bin. This is bin 1, this is bin 2, right? So here the width are very important, and also there could be of different widths. Okay, because here what happening, the bin 1 is, see, bin 1 is from 5 to 11. See, 5 to 11 is my bin 1 in age column. This is age column. And one more bin is 11 to 16, 11 to 16. Getting? And third bin is, see, 16 to 18, 16 to 18. Getting? So there is no any disconnection from 5 to 11 first bin, and from 11 against 11 to 16, from 16 again 16 to 18. So since it is continuously like joining one bin to another bin, that's why there will be no gaps, there will be no gaps. And the widths could be different, it will be always be continuous. That means there will not be any gaps between the width, and the width could be sometimes of different width also. Okay, the bars which you are seeing, right, there might be of different widths. Okay, and this is for the continuous, this is for the discrete. Okay, so is this clear guys? Any confusions you are having in bar graph and histograms, please let me know. Okay, so if you think about it, actually if you think about it, in the histograph, if you just try to yeah, see guys, just to tell you one point over here. So the histogram, okay, as I said, if you taking for the range of 1 to 10, okay, 1 to 10, if you're taking few bins, if you're taking few bins, that means what I will consider my range 1 to 10, 1 2 3 4 5 6 7 8 9 10. Okay, these are the complete range. Okay, so now if I consider each unit as one bin, then how many bins I will have? Bin 1, fine. Bin 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 bins you will have. Okay, you will have 9 bins. Fine. So that means what? The width will be very small bins. So that means what? Bin 1 might be just this much. Okay. Bin 2 might be this. Bin 3, bin 4, bin 5. Okay, this width are always equal, because every bin is of one unit difference, 2 minus 1. Okay, 1 1 1 1. Fine. But and the point I'm trying to make over here is when you're having more number of bins, okay, when you're having more number of bins, fine. Okay, I'll just draw one more thing so that you will have understanding. This is, if you can divide this into this way, okay, or you can consider little wider bins, okay. That means what? I don't want each unit, I'll say from 1 to, okay, from 1 to 4 you will consider one bin, 4 to 8, okay, 8 to 10, 3 bins, okay. B1, B2, B3, okay. Now in this case, this is first. The second case, what will happen? So 1 to 4, 4 to 8, 8 to 10, fine. So 1 to 4 might be this, 4 to 8 might be this, 8 to 10 might be this, fine. Same range, you can divide it into any number of bins. In the first scenario, observe here, in the first scenario I'm dividing into 10 bins, so 10 bins, so the width of each bin will be shorter, okay. So see, like I might not have drawn very perfectly, but here if you think, when you're having 10 bins, right, so same data, if you divide into 10 bins, the width of this will be very, very small because you're having 10 values. But if you divide the same thing into what, 3 bins, the width will be bit more. Agree? Width will be bit more, fine. And that is regarding the width, guys. But if you also see about the frequency, that means this graph, this horizontal, this vertical graph, so what is this speaking about? This is speaking about the frequency, right? Here from 1 to 10, see here 1 2 3, right, 1 2 3 4, like that. First bar is what? From 1 to 2, how many people are falling? What is the frequency? From 2 to 3, what is the frequency? 3 to 4, what is the frequency? Agree? But here 1 to 4, right, from 1 to 4, what, how many values are we are having? From 4 to 8, how many values we are having? And 8 to 10, how many values we are having? Okay, so regarding the horizontal, regarding the x-axis, if the bins are more, the width will be less. If the bins are less, the width will be more. That is one point regarding the x-axis, the bins. Coming to y-axis, which is frequency, you can clearly think and see that if you are having more bins, okay, if you are having more bins, fine, so the number of values which are falling into each bin will be less, because you have more bins, there are so many options for each number to fall into. Agree? So the height of these bins will be a bit less when compared to this, because here you are having only 1 4 8. So overall if you're having, let's say, 1,000 values, okay, so all these 1,000 values in the second case should fall into either one of these 3 bins. Agree? Either one of these 3 bins only it should fall. Getting? So here, out of 1,000 values, all should fall into only the first bin, second bin, third bin, okay. So there will be more number of values collecting into each bin. Agree? So from 1 to 4 you might have, roughly you might have 300. From 4 to 5 you might have 500. Okay, from 8 to 10 you might have 200. Fine. So the height of this will be actually like this, okay, little height, okay. But here in this scenario, same 1,000 bins, how many options you have? 10 options you have. 1 to 2, 2 to 3, okay, 9 options you have. 1 to 2, 2 to 3, like that, okay. So from 1 to 2, just as example, from 1 to 2 it might be some 100, 2 to 3 it might be 150, like that, right? So what are these are frequencies, right? The height of each bin will be not that grateful, but you will have more number of bins. Okay, it will be shorter bins but more number of bins if the bins are more. If the bins are less, okay, less number of bins but little height bins, okay, longer bins, taller bins. Okay, if the bins are more, the width will be less and the height of the bins will also be less. Correct? But if the bins are few, the width will be little more because you are dividing it into larger width. Okay, and then the frequency will also be more. The height of each bar will also be more. Fine. Is this clear, guys? Are you guys on track, or did you miss the track? Did you understand what I was trying to explain?
Fine, Santosh.
Okay, any confusions over the Karthik? So
No, Santosh. It's completely like we have huge data. I mean, like if we have bins are more, then each and every bin data will be less, right? Anyway, like
Correct.
so frequency will be less. If it is combined, then automatically bins will be more. Sorry, if free bins are less, frequency is more. It's just opposite, right? Inversely proportional.
Correct.
Yeah.
Correct. If bins are less, frequency will be more. Fine.
And in histogram, like we don't, it's continuous, right? That's why we have data in the form of continuous in a
Correct.
graph. And it is, in case bar chart, we don't have any continuous, like it's completely discrete. So it's not continuous.
Correct. Correct.
Yeah, we can see the gap, right? That is also
A gap in where? Gap in bar.
in bar chart,
Bar
because
chart.
it's a discrete.
Correct. Correct.
Yeah.
Okay. Fine. So I hope you have a good understanding about now histogram, what is histogram and what is bar chart. Okay. By looking only you can able to understand. Okay. Fine. So that is regarding this two graphs. And third thing, you have something called as scatter plot, guys. Okay. So scatter plot we are going to see, okay, in bivariate analysis. Okay, so it's the same thing out there. Fine. So till now what we have seen, that is for the single column. That is for the single column. Okay, that means what? If given one column, I want to understand this column, what I should do? Fine, what I should do? So you can draw these graphs. Okay, you can draw histogram, bar plot. Okay, and you can understand what type of nature it is having. Okay, but now coming to now extending this to two graphs. Okay, if you extend this to two graphs, it's called bivariate analysis, guys. Okay, now over here in bivariate, what are the different types of combinations you can have, guys? Fundamentally, what is data? How many types of data did we divide into? We divided into categorical, numerical at high level. Agree? So now how many combinations are possible? One is categorical. That means if I have two columns, what are the possibilities? Okay, categorical. Second thing is numerical. Agree? Third thing is categorical numerical or numerical categorical. Anything fine. Fine. These three types of combinations are possible. Okay, if you are working on any two columns. Okay, any two columns. That's why it's called bivariate analysis. Okay, two columns. Okay, so now let's see. Let's try to see how you can understand how you can work upon all these three combinations of data. Okay, categorical, numerical, all this. Okay, so now see, you are studying this, right? So obviously, so very soon you will understand the importance of this, right? Because the data which you are going to get over here, right, on the when you are actually working on machine learning, the type of data what you are getting, you will not be knowing like anything in hand, right? So any type of data you might get, even in any type of project you work on, the data what you get will mostly be a combination of this. Few columns will be continuous, few columns will be categorical, few columns will be discrete. Okay. In also in few columns it will be categorical, but only two categories, male and female, or it might be like more than 10 categories you will have. Okay, so it will be complete mixture of all these types of data which you will get, right? So obviously you should know how to handle each type of column and each type of data. Fine. So just to giving you a longer vision where you are going to use this. Fine. So coming back, first type of data, just categorical and categorical. So to understand this type of data, you can use something called as contingency table, guys. Okay, so it is nothing. So the concept is not as hard as this pronunciation. Okay, it's very simple. So what does this mean? Contingency table is a tabular mechanism. Okay, tabular with at least two rows and two columns used in statistics to present categorical data in terms of frequency counts. Okay, it's just a tabular mechanism, okay, to represent the categorical data in terms of frequency counts. That's it. It's just representation. Okay, for example, if you see over here, we're having two categories. We're having two categories. One category is what? Gender. And second category is what? not category, I can say one type of one column. Okay, one column is gender, other column is the taste. Okay, you can simply call taste or something. In gender, in this column, there are different categories: boy, girl. In taste, they like or don't like. Okay, so this is one category. This is one category. Fine. So to understand this, you can just draw this table. So in this form, so where it will where you will consider all the different combinations of this. Okay, all different combinations of the complete possible outcomes. Okay, so in boys, how many people are eating Snickers? How many people are don't like Snickers? Okay, girl liking, not liking. Okay, get it? This is something similar to the what we have seen, the correlation, right? Correlation matrix we have seen, right? For each and every xy xx combination, xy combination, yx combination, yy combination. Fine. So we have seen certain values, right? Similarly, so you can draw a contingency table to understand the categorical and categorical data. Fine. So this is just basic idea. We will see how we can use this. Okay, so using contingency, you can try to understand clearly all categories, what are their frequency. Fine. So this is a frequency. What is this 43? 43 is a frequency. Frequency of what combination? Boy plus Snickers. 19 is what? Girl and no Snickers. Okay, this is the value. Now coming to numerical and numerical data. Okay, coming to numerical and numerical data, you can use something called as scatter plot. Okay, we can use something called scatter plot. Okay, so fine. So here we are going to see a scatter plot. Okay, scatter, it's called scatter plot because the graph will be, the values will be scattered. Okay, dispersed all over the space. Fine. So let's see how can we draw a scatter plot. Fine. So see, we are creating a data frame, simple data frame, like from numpy. Okay, if you don't understand this, that's fine. Okay, don't worry. But what's happening over here is we're just creating five columns. Okay, we are creating five columns from this data. Okay, rand 105. Okay, see what does rand 105 will do. Let's try to first understand. Okay, what is the function here? Having random dot rand. Okay, so random dot rand. Okay, what does it give? Numpy random dot rand. Okay, so returns random values. Okay, this is a convenience function, takes a tuple to specify the size of the output, which is consistent with the numpy function. Okay, 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 so it's giving you the shape. Okay, output is the random values, three columns, sorry, three rows, two columns. Okay, so that means what? 100 comma 5 means 100 comma 5 means 100 rows. Okay, 100 rows it is creating, and 5 columns it is creating. Okay, this is a 5. So randomly it will create a table. Okay, first of all it will create a table whose shape is 105, means 100 rows. These are rows, right? 100, and these are columns, right? This will be 5. Okay, so that means total how many values will you have? 100 into 5, 500 values you will have, and all those 500 it will generate randomly. Okay, randomly it will fill all these table values. Clear? So that's why we are having 105, 5 columns we are creating, and name of this each column is A, B, C, D, E. Okay, like that we'll have 100, but we are seeing only 5 because here if you see we are saying head. Okay, head is a function, pandas function, where if you say head, it will show you only top 5 values from the data frame. Okay, we'll see that in very detail in pandas. Okay, but you have head, you'll also have tail. If you say tail, it will show bottom 5. We are saying head, it will show top 5. Okay, so fine. So now the important point is how to draw a scatter plot. My data frame is df scatter. Okay, similarly plot dot his plot dot bar, you also have df dot scatter. Okay, df scatter dot plot scatter, I'm plotting two graphs. Okay, x and y. See, all these points, okay? So to plot any point in space, fine, to plot any point in space, you should have at least how many coordinates? Two coordinates you should have, right? If I say 2 comma 3, so that means what? On x-axis it is 2, on y-axis it is 3, wherever these two are meeting, so that will be the point. Fine. So to plot any point, you should have at least 2 points if it is two-dimensional. If it is three-dimensional, you should have 3 points. Fine. So here also, I'm mentioning two columns, x equal to a, y equal to b. That means what? My x-axis, this is y-axis. My x-axis is column A, y-axis is column B. Fine. So that means what? A and B. So first value from X and first, sorry, A and first value from B will be taken and plotted. Okay. So 0.16 and 0.5. Okay. So 0.16 will be somewhere over here and 0.5 will be somewhere over, I think, this point. Okay, guys. So 0.16 might be here. Okay. Sorry, just give me a second, guys. Hello. Hello. Yes. Yeah, sorry guys. Fine. So looks like this is that point. Oh, so like that it will take each pair from this. Okay, this these two will be one pair plotted, this will be one pair plotted. Okay, so that's how this graph is created, guys. Every point you see is a combination of two values, one value from X, that means A, and corresponding value from B. Okay, so this is how the scatter plot can be created. Okay, and similarly you can also go for, okay, in plots you have like lot of parameter, guys, you can play with that, but as you can simply see, d of scatter dot plot dot scatter x equal to a b. Okay, this is for you are drawing a and b columns, and to just to differentiate, you are saying as color should be dark red. Okay, and similarly you can also draw one more scatter plot called as C and D. Okay, color is some dark orange. Okay, fine. So now if you see all this red or dark maroon sort of things are A and B plots. Okay, that will be exactly same as this. Okay, this graph will be exactly same as this. Wherever you are seeing the wherever you are seeing the what, the dark brown. Okay, for example, if I show you here, here you're having two like joints, right? So here you're having 2 points nearby. Okay, this is A and B graph. Okay, similarly here also you are drawing A and B graph in the dark red. Okay, I think those points are here. Okay, you can see these two. Okay, you can see these two, right? So these are the same as A and B, but newly you are drawing C and D also. This is the dark orange. Okay, wherever you see these orange plots, right? So these are the C and D graphs. Okay, so using that, okay, you can also mention some ledge. These are called ledgers. That means to understand, if you just see the graph, what are these points? It's okay, you can just say this dark color is for length and this is for the width. Okay, so you can use any names you want to give. Okay, just by looking at this graph also, sometimes you can understand. Okay, so the other day when we are trying to understand what the covariance or correlation part, right? So the correlation between two columns, we have discussed that if it is this positive, if it is this negative, if it is like this, okay, like this is no correlation. Okay, if it is completely like this, no correlation, right? So over there also you can use this scatter plot, will be actually helpful. Okay, so that is actually the first thing, one of the first thing we'll do when given a data frame. We will take two columns, okay, and we'll try to understand what is the relation. So for that, if both are numerical, okay, if both are numerical, and numerical. Okay, the input and output is also numerical. Fine. You can simply plot a scatter plot. Very simple, right? Data frame dot plot scatter, give column A, column B, okay, and give some color, it will plot. Okay, but if at all this is by sorry, by looking at this you can clearly say what is the correlation of A and B, guys? Can someone say A and B, what is correlation? Is this positive or negative?
It's no relation.
No relation, right? So this is no relation. Okay, but if this graph looks like something like this, okay, if the points are like this, okay, something like this, okay, you can clearly see it is a positive correlation. Fine. So if something like this, okay, a negative correlation, right? So just by graph, simple graph, you can understand the relation between two columns. Getting? So that is one of the very importance of scatter plot. Fine. So from using the formula, you can get, using the formula, obviously you can get some, you'll get the value between -1 to +1. Okay, -1 to +1, you'll get the range of the correlation. That's fine. Okay, but before that, many a times it is very helpful, and it also gives a one more dimension for you to understand, okay, or to represent to someone what is the relation between these two. Okay, what is relation between these two? First of all, can I use the correlation or not? Okay, just because two both are numerical values might not be always they are correlated, right? We also seen correlation causation also. Fine. So just to understand what is the relation between these two, you can simply plot a graph and understand and get some basic idea how does this interrelated. Okay, then you can apply this correlation part. Okay, so regarding the correlation also, right, so I will also show you a simple way how you can find out the complete correlation of all the columns in a given data frame. Okay, we have okay, just reminding you. Okay, so we'll come to that. Okay, but coming back, scatter plot is this, guys. Clear? So you can simply use df dot scatter dot plot, okay, for the numerical and numerical. Fine. So these are for numerical. Obviously you can see you cannot do it for categorical numerical. Okay, those are, over there comes the frequency part. Fine. So I think now you are able to understand when I say, when you are having only categories, okay, only when you have categories you will have frequency. Agree? When you have categories you will have frequency. Fine. And even if you have a continuous data, you can convert them into bins, and there also you are sort of converting into categories, and you can find out the frequency. Fine. But now as a next step we are studying a combination of two columns. Okay, here if you are having two columns, both categorical and categorical, that's fine. You can simply draw a graph and understand what is the frequency distribution of each and everything. Okay, but if both are numerical, what to do? If both are numerical, you can go for the scatter plot. Okay, you can go for the scatter plot and understand the graph, because here you don't have any frequencies at all now. Fine. You cannot convert this into categories, again this into categories. Okay, will not make any sense. Fine. So if both are numerical, right, it is very simple. You can just go for the scatter plot. Getting is scatter plot clear, everybody?
Yeah, Santosh. But can you please once explain that how those frequencies will occur? I mean, in between A and B in that graph.
Which one, man?
Can you please open that graph? Scatter
Okay.
graph. And how to place the dots, like based on that's what I am getting confused.
No, it only no. See, each point is, see, Karthik, see, simple. This is x-axis, y-axis. Okay, forget
Yeah.
about this. Forget about this. Now on x-axis, what we'll have? This is 0 origin. 1,
Yes.
2, 3, 4. Okay. Now on y-axis, we'll have 1, 2, 3. Okay. Simple school trigonometry. Trigonometry only. We have studied, right? So here, if I ask you to plot 2, 2, what you will do? On x-axis point is 2, on y-axis point is 2. Both where you will join, both where joints, that will be the 2, this point is called 2, 2.
Correct.
Same thing you can do it for anything 4, 3, 4, 3. This is 4,
Yes.
3. Similarly here also, what we are having, if you are considering x equal to a, y equal to b, that means column A and column B you are considering. Okay, and column A is having how many values? 100 values you are having. column B is having how many values? 100 values you are having.
100
So
values.
what it will do now, to plot each point is what? Each point should have two coordinates. One coordinate will be coming from A, one coordinate will be coming from B. That means what? It will internally convert all this into different pairs. First pair will be 0.16 comma 0.511, whatever you are having over here. Okay, first value from A, first value from B. This is first pair. Second pair of values 0.6 comma 0.9. Okay, 0.6 comma 0.9. Okay, so like this it will consider 100 pairs. Last 100th value from A and 100th value from B. That will be last pair. Now simply you have the coordinates. You can come here and plot, right?
Okay, got it.
Exactly the same thing. You
Okay.
sorry.
Just a pointing like a graph.
Pointing, just it's pointing. That's it. It's just pointing. Nothing much.
Okay.
0.16 over here. That's why I'm saying this is 0.0. This is 0.2. You'll have 0.16 over here on the x-axis. Okay, this is A, and y-axis is 0.5. Okay, somewhere you will have 0.5. Okay, this point, as you can see, is the first point from the A and B. Okay. Similarly, each and every point it will plot. So overall 100 points it is plotting. Just it is pointing, taking a pair, considering one pair from A and B and pointing that, plotting that. One second pair plotting, like that it is doing. Is that clear?
Yes. Thanks.
Okay. So scatter plot is clear, guys, for others also. Very simple graph. Okay. Fine. So now, what if, so we have seen for categorical and categorical, we can go for contingency table. Okay. For numerical and numerical, you can simply go for the scatter graph, scatter plot. Okay. But if you have categorical and numerical, okay, if you have categorical and numerical, fine. So what you can do here is, that means what? For example, if you have a particular column as 6, right? So it can take two values, 0 and 1. Okay, one could be female and anything. 0 could be female and 1 could be male. Okay, this is a categorical column. Okay, only two categories. Okay, for this, if you have a continuous numerical column, okay, numerical, it could be discrete or continuous. Fine. So let me take age. Okay, now age. Fine. So now coming to age, which is numeric column, fine, and a discrete numeric column you can call. So if I have two columns, 6 and age, okay, categorical and numerical, fine. So use here, what you can do here is, so that you can handle different ways. One of the simple ways, if you want to plot here is, so that means what? Here what's happening? So you are having, see, this is the one column, okay, and 0 and 1, okay, and okay, for understanding, this is female, okay, this is male, okay, and over here you have age. Okay, age can be anything, 0 to 20, 20 to 40, 40 to 60, right, 60 to 80, 80 to 100, okay, 80 to 100, fine. So one way is you can create a table. Okay, you can create a table. So from 0 to 20, how many female people are present? Okay, so like that you can get the frequency. Or usually what we will do when we have categorical and numerical data, we take the mean of the age column. Okay, we will take the mean of these values. Okay, fine. So for 0 to 20, 20 to 40, 40 to 60, right? So you can take the mean of all these ages, okay, for female, and you can point mean of ages of female. Okay, and similarly you will have other values, fine. So for male, for all these ages, you will have all different values, right? So from 0 to 20, it could be what? All these values could you can have 5, 8, 9, okay, also all kind of different values you might have. For 20 to 40 also you can have different range of values, 40 to 60, fine. You can take the mean of each this, okay, mean of each this, and represent that as the mean of age comma male. Okay, so then you can just plot, you can just try to plot. Okay, on x-axis it is 0 and 1, 0 and 1, and just for 0 what is the mean, and 1 what is the mean. Okay, age column. Okay, so but you can also go into, you can also consider different means for 0 to 10. You can divide this into different columns as we have seen here, and you can consider only 0 to 20 what is the mean. Okay, for 20 to 40 how many people are falling and what is the mean of them. Okay, you're getting right, the 40 to 60 is the range, and there might be, let's say, like 30 people whose age is between 40 to 60, and those are female, right? So, and that means what, you will have 30 values between 40 to 60. It could be 41, 48, any values, any possible values, 30 values you might have between 40 to 60, and those are the female. So you can take a mean of this, mean of this value, mean of this value. And if you want, you can plot individual means also, but also you can take the overall mean also, you can take and just plot for the understanding. For 0, what is the overall mean? That means for female, what is the average age? Okay, and for male, what is the average age which you are having? Okay, so in this way, basic simple plotting also you can understand categorical and numerical part. But however, when we are actually handling these columns, right, you will have a better understanding. Okay, so this is just an introduction. Okay, for you guys, just to giving you sense like what all types of data you will be facing and you will be getting exposed to. Okay, so fine, I would say that's the topic which I want to cover today. Fine. So we have seen, just to give a recap. So this actually, the frequency distribution is very important, guys, because from tomorrow or day after tomorrow's class, when we speak about the probability distribution, it is completely based upon the frequency distribution itself. Okay, so just make sure you really understood the what is frequency distribution, right? So go through the class, that is my recommendation, otherwise it will be very difficult for you to understand. Okay, so this is, as I said, these are not, see, scatter plot, just one important point if I want to make over here. Scatter plot is what? So if I'm having some value on x, I'm having some value on y, take one value from, as we have seen, a column we are having some value. Okay, a1, b column we are having one value, b1, a1, b1, you are plotting, it's just plotting, right? Till now from school we have seen just plotting, you have two values, you will plot. But coming to frequency distribution, these are completely different, these are not normal distributions. Here the x-axis will be the outcome, guys, always remember, I'm repeating this 100 times because this is very important. And y-axis is a frequency. Fine, so age from 0 to 10, that is outcome. Okay, and what is its frequency? 10 to 20, what is its frequency? Okay, this, that's why you will get a frequency table. Okay, the y-axis will be the frequency. Fine, so make sure you understand that. Okay, so because it's, we are going to see more detail. Fine, so then we have seen categorical. Okay, and we understood numerical, why you will convert into bins. Fine, so Sirisha, you once go through the class yesterday, you will understand why you are using bins. It's very simple, it's basically we are just dividing into buckets, groups. Okay, and then we have seen the histograms. Okay, how you can draw for the continuous data, different types of graphs, types of histograms we have seen. And then we have seen the bar plot, right? We also seen the bar plot. Okay, just give a recap. Okay, and we understood what is the difference between bar chart and histogram. Okay, histogram fundamental for the continuous. The width also we have spent decent time understanding what is what should be the width of each graph, and why there are no gaps, why there could be gaps, what is a width, is a width having any importance over here? No. Is a width having any importance here? Yes. Okay, so those things we are able to understand. Clear? And coming to bivariate, we understood like what is categorical and simple contingency table, numerical. So okay, we can go for the scatter plots. Okay, and plot different types of graphs. And for the, sorry, and for the categorical and numerical also, you can go for the, by the mean concept, you can try to plot the categorical and go for the individual means or the overall means. Okay, so these are the concepts I would say which we able to cover. Okay, from tomorrow we are going to cover a concept, start a new concept called as, very important concept, that's called as percentile. Okay, very interesting concept and very fundamental concept, percentile. From this only, there many concepts will arise. Okay, you will see something called as box plot. Okay, very important graph, a very important concept. Okay, box plot. And then using this only, you'll also understand outlier detection and how to handle outlier. Okay, the fundamental concept called as percentiles and quantiles. Okay, so tomorrow we are going to start this. Okay, once this concept, this is a very specific concept. Okay, and you will have like 3-4 like related concepts. Once we are good with this, once we understood this perfectly, right, then we will go and actually study the core part of the statistics called as probability distributions. Okay, see guys, once you are able to understand these basic concepts, you can definitely understand probability distributions. And once you are done with the probability distributions, right, you are very good. Basics of statistics will be never difficult for you. Okay, after that we have some concepts, but till now if you understand these are all the basics, fundamental concepts. Okay, tomorrow, till what, as I said, whatever we are going to study tomorrow, the percentiles, etc., if you understand till that, your basics are very good. Okay, and if you understand next probability distributions, then you will be at intermediate level for the statistics, and then you have few more concepts, fine, that we are going to see. But yeah, but let's take one step at a time. So as actually my plan is to complete percentiles by today, but that's fine, I'm going a bit slow. Okay, so taking only one step at a time. Okay, so that you will have some time to grasp things and revise the concepts. Okay, so fine guys, that's all for today. Okay, please make sure you start making notes, and if you're not understanding the class, go through and rewatch the class. Okay, fine, are we good guys? Any doubts, or is the class clear today?
Yes,
Clear.
Santosh, clear.
Okay, fine, let's meet tomorrow. Thanks guys, bye.